In this presentation, we're going to explore the many issues that contribute to system malfunctions. We'll start with the signs of trouble, which usually means the end user is calling in a panic. And then we'll look at the septic tank. The tank supplies the primary means of treatment, and its proper installation, assembly, and maintenance are critical to the system. After that, we'll look at the EnviroSeptic field itself. Throughout the process of troubleshooting, our goal is to find and correct the root cause of the system's malfunction. When we're successful, a method called rejuvenation can often be used to put the field back into long-term service. And finally, we'll discuss a common complaint, odor, and what can be done to discover the reasons for it, and ultimately the solutions. Let's get started. The most obvious sign a field is in distress is the growth of lush green grass directly over the field. This is usually an indication the ground has become saturated, and there may also be an intermittent odor in the area of the field. Pictured in the upper left is a good example of a field in trouble. The homeowner confessed that the grass had been getting greener for a number of years before effluent finally broke to the surface. If this condition manifests itself within the first year of operation, it is usually an indication of a serious problem. We've found that the most common reasons a system floods during the first year of operation include compacted receiving layer under the bed, system sand with a high silt content, assembly issues, and owner abuse. Even before the grass begins to show signs of a problem, it's common for the septic hauler to warn the system owner that there was backdrain from the field when they pumped the tank, which is a sure sign of a system in distress. There have been occasional systems that didn't show any signs of trouble until the effluent broke to the surface. But once we're aware there's a problem, what do? My answer is to start at the septic tank. Because the septic tank provides primary treatment to the waste stream, it's critical that it's sized properly for the daily flow, has adequate baffles, and the most overlooked requirement, tank maintenance. The tank shown here was in serious need of pumping and was also undersized for its use. By the owner's admission, this tank had not been serviced for 5 years, which was how long they had owned the property. To make things worse, the home was being used well beyond the system's design capacity. Solids did find their way to the field. So the primary reasons for the field flooding was overloading, and the tank was always too full to allow airflow through the field and up the roof stack. The system owner took measures to reduce the daily flow and had the tank serviced, which addressed the root causes of the malfunction. The field was successfully rejuvenated and is still in operation today. And from another system, the D-box pictured here is downstream of a grease trap that has not been sized properly and was in need of more frequent pumping. If grease is allowed to enter the field, it is unlikely to recover quickly, if at all. The lack of tank maintenance in commercial systems can be a very expensive mistake. Effluent filters are commonly used to try and keep the solids and sometimes grease inside the tank. However, as you'll see, they pose their own problems. As we discussed in an earlier presentation, effluent filters do block large solids from getting to the field. But don't assume they filter all of the finer solids. You can see here a D-box that is downstream of an effluent filter, and clearly fine material is getting to the field. This is less problematic for EnviroSeptic fields because the pipe acts as an additional settling chamber, where those solids will be digested by the aerobic bacteria. The most common problem with effluent filters is the lack of maintenance. These filters can become clogged enough to restrict or eliminate airflow from the field. And you'll remember that our goal is to keep the field aerobic. A simple draft test will determine if the filter is restricting airflow. I'll show you how to do that later in this presentation. If the system's tank has regulation inlet and outlet baffles, there is no need to use an effluent filter with EnviroSeptic systems. Some common problems related to baffles are shown here. We've seen baffles broken completely off, or they were never glued together when installed, resulting in solids having an unobstructed path to the field. Proper inlet and outlet baffles provide a means of keeping the majority of solid material in the tank, and just as important, a means to exhaust waste gases while helping the field to draw air through the soils or low vent. Concrete baffles are very common, especially in older tanks. Pictured here on the right is an outlet baffle that doesn't allow air to pass through the tank and up the roof stack. The solution was to drill holes in the concrete covering the top of the baffle. PVC baffles are more common today, but must incorporate a sanitary T, which is simply a T with the top left open for airflow. The rules specify there must be a minimum 1-inch gap between the top of the T and septic tank to allow for airflow. This applies to both the inlet and outlet baffles. Notice the ring impression left on the bottom of the tank cover in the lower left picture, indicating it is in direct contact with the top of the T, which of course will eliminate the possibility of airflow. We've seen these kinds of problems contribute to field suffocation. Groundwater infiltration can be another significant problem for a field. This occurs when a tank is placed too far into the water table or has leaks. If a tank is placed too far into the ground, a common source of water is the leaking riser. Be careful if you choose to use an existing tank that you suspect has inlet or outlet pipes in the water table. A leaking tank can be difficult to discover. If you're going to use an existing tank, have it pumped and watch for any signs of leaking. And it goes without saying, never climb into a septic tank that's been in use. There can be asphyxiating gases that will linger in a tank and can easily render you incapacitated. Leaking tanks should only be repaired from the outside or entirely replaced. A less obvious problem is sagging lines to and from the septic tank. This can occur after a new installation where the soils have settled or the line may have been driven on. The result can be a water trap, which again will stop all the required airflow. A draft test is the easiest way to determine if this is the case. During installation, try not to over-excavate your ditches and be sure to compact the soils under the sewer lines. I would also add that even though sewer and drain pipe is allowed in most locations between the tank and field, I would recommend using glued Schedule 40 PVC. This is cheap insurance against a crushed line and will help resist any potential sagging. Now let's turn our attention to the field itself. We're going to discuss a number of the more common problems we see when investigating why a field went down. The first issue will be the system sand surrounding the enviroseptic pipes, and others are improper raised connection assembly, and finally site preparation. You'll remember the system sand has been specified to be coarse enough to allow the sand voids to hold air, yet fine enough to help wick water away from the pipes. If the system sand is too fine, it will retain water, forcing the field into an anaerobic condition, or starve for air. If the system sand contains too much silt content, that silt can find itself washed to the bottom of the sand and can create a restrictive layer or drastically reduce the ability of the sand to shed water back to the underlying soils. If you get asked to troubleshoot a field, I recommend you sample the system sand at each end and in the middle of the field. These 3 samples should be mixed together before the analysis and will be a more representative sample of the entire field. Pictured in the upper left is a field that didn't have the required 6 inches of system sand over the pipes, was backfilled with dense clay-like material soils, and was buried too deep without venting. The picture in the lower right shows an installation that used absolutely no system sand at all. Here we see errors by inexperienced installers. The installer that placed the plastic tarp over the entire field was trying to keep sand from infiltrating the enviroseptic pipes, much in the same way you would use straw for a pipe and stone field. The other picture shows a layer of silty material directly over the pipes. It turns out the surface waters were not diverted away from the construction site, and when it rained, they ran directly into the field before it could be backfilled. The installer either didn't notice or understand how this could be a problem. Surface grading and or siltation fencing could have prevented this problem. Enviroseptic systems have very few components to install, and many of the assembly problems we see, again, result from inexperience. In the upper left, you'll see a field where the offset adapters were placed in the 6 o'clock position. First, that doesn't allow for the full use of the pipe's liquid capacity, but more importantly, it doesn't allow for any airflow through the field because the raised connections were full of water, which effectively created water traps between each of the rows. Also shown is a picture of a field using sewer and drain pipe that had only been assembled by press fit, but not glued. You can see the raised connections have pulled apart during backfill. Although gluing your fittings is not required, it's recommended for this reason. The enviroseptic pipes shown touching each other are again a result of careless backfill, with the raised connection being pulled entirely out of the pipes. Because liquid can't get to the other rows, this field operated for 7 years on only one row before failing. In the lower right, you'll see where the raised connection was extended so far into the offset adapter that it was actually underwater, as indicated by the black anaerobic deposit on the pipe. Again, this created a water trap, blocking all airflow through the field. Raised connections should only extend 2 to 4 inches into the offset adapter to ensure proper airflow. In the upper left, you can see the result of a homeowner's frustration with having the low vent placed in the middle of the lawn. After the installer left, the vent was cut flush with the ground, and it then became a drain for all the surface waters. Using remote venting would have helped keep it out of view and safe from tampering. In the upper right, you can see a problem that we encounter all too often. The D-box is settled because it wasn't placed on firmly compacted soils and is no longer level. This can send the majority of the liquid to only a portion of the field. Using flow equalizers can help correct this problem. If they were installed at the time of original construction, they would have helped compensate for some D-box tipping. You'll remember our rule that if flow is divided, flow equalizers are always required. A critical assembly problem is shown here, even though it's not all that common. This is a field that was installed on so much fill, it settled on one end to a point where it was 6 inches out of level. That and the enviroseptic pipes were installed perpendicular to the original grade. For years, the owner reported the grass was always greener on one end of the bed. They also reported odor at certain times of the year. It lasted 7 years before it finally broke to the surface. When placing large amounts of fill under only one end of the field, as in this case, be sure to place the enviroseptic pipes parallel to the original grade and use serial distribution. If the fill below the downslope rows settle, it will have no effect on the function of the field. It will effectively become a sloping system, but in the correct way. Now let's talk about some site preparation issues. In the upper right, you see a picture of a D-box that has a serious case of root infestation. Trees were left within 8 feet of the D-box. It didn't take long for the tree's roots to find that high nutrient water nearby. Be sure to keep deep-rooted vegetation or water-loving trees well away from the field. Use the tree's canopy as a rough indication of how far the roots extend. If the tree is young, project its growth and remove it if you think it will present a problem in the future. In the upper left is a system where the organic material, grass in this case, was not completely stripped from the receiving layer before assembly. In your troubleshooting, consider using a hand auger to examine the soils directly under the field. In the lower middle, we see the result of not properly preparing and/or compacting the receiving layer with construction equipment during site preparation. Also, a field placed lower than the design intent can have the same effect, especially if the soils become denser at the lower elevation. Remember that wise advice, measure twice, cut once? Always double-check your elevations during construction, and remember to keep your equipment out of the basal area. And remember that in order for the EnviroSeptic field to function properly, it must not only have a properly prepared basal area, but 6 inches of system sand below and above the pipes. Before we leave this slide, notice in the lower middle a small diameter plastic pipe is shown. It turned out to be lawn irrigation. We do not allow any irrigation on the field or its spray within 10 feet of the field. Now we're going to discuss the rejuvenation process. The first thing you should do is call us for technical support. We have an interest in knowing why a system failed and passing that on in our training. The most important part of the process is the need to know what caused the field to flood. If the root cause isn't addressed, rejuvenating the field will only be a short-term fix. Sometimes a cause may not be obvious and we're left to a process of elimination until it leads us to an answer. Part of eliminating the issues is to confirm the field was constructed properly with the required system sand, site preparation, etc. But before we can do that work, we have to drain the field. Start by having the tank pumped. This will usually allow up to a week of drying time for the field. Next, a trench needs to be dug at the far end of the field to retain the effluent, but still allow it to drain the field. Once the field has aerated for several days and its reason for failing has been determined, it can be put back into service. If venting isn't present, it must be added before backfilling the system. In the upper left, you see a rejuvenation ditch at the end of the field. Dig the ditch 6 to 12 inches below the EnviroSeptic pipes. This will provide the means for water to drain out of all of the rows. Remove all of the offset adapters or end caps to help with the aeration. If there's a D-box, expose it and open the lid. This will add to the airflow. If you find accumulations of solids in the pipes, you should flush them from the D-box end. If there isn't a D-box, you'll need to expose both ends of the rows. While the ends are visible, check the field for level. The field should be within 1 inch end to end. Depending on how long the field has been flooded, you'll see varying amounts of black anaerobic sand around the pipes. This black color will slowly diminish as it is exposed to air. This process happens more quickly during the warmer months. Be sure to safeguard the open excavation for safety reasons, and once the field has had at least 72 hours of drying time, it can be reassembled and backfilled. Other common causes for system trouble are grease, especially in commercial applications. We typically find grease traps sized for too little retention time, which doesn't allow the grease to solidify. Call us for recommendations, but in general, tankage is the answer along with proper pumping schedules. Water softeners can add additional loading that wasn't accounted for in the field's design. We recommend the water treatment backwash be directed to a separate dry well or field. Garbage disposals are one of those appliances that often get added after the fact, and the tank may now be undersized. That and garbage grinders can be severely abused. We came across one owner that was using her grinder for a way to dispose of newspapers. Unusual chemicals or high quantities of common household items can inhibit the field's biology. Petroleum products are a good example. We've found garage floor drains plumbed into the system, and the owner was using it to dispose of motor oil. With older homes and commercial operations, you may have to work really hard to discover these abuses, or send a sample to the lab for analysis. Overloading a field is another common issue, and leaking fixtures can be the culprit. I was involved in a failure due to a leaking toilet flapper. The owner used the facilities just before leaving for an extended trip, and the caretaker noticed water slowly flowing out of the low vent at the base of the field 3 weeks later. If you're on a site having trouble, you might listen or look for water entering the tank and ask the owner if there's any reason for water to be running. Leaking fixtures can add huge amounts of water to a system that it wasn't designed to disperse. And that brings us to one of the most common issues, vent odor. Vent odor is probably the #1 reason for vents disappearing. Owners get frustrated and simply don't know what to do. First, you'll remember we discussed how the low vent attached to the field is the air inlet, where the high vent or roof stack is the air outlet. If odor is coming out of the low vent, it usually means there's no draft, and the issues we just addressed, like sagging lines or effluent filters, may be the cause. When the draft is restored, the odor will subside or disappear. Related to draft problems is the size of the roof vent in gravity systems. If the home is older, it may not have an adequate roof stack. In that case, an additional high vent may need to be attached to the septic tank, which will provide the necessary airflow. A blocked roof vent can have the same effect. Pushing a garden hose down the roof vent with the water turned on can often dislodge a blockage. One of the most difficult things to understand is why vents get placed so close to recreational areas, like a deck, or even near a home's windows. The pump chamber vent is a common offender in this respect. Move the vents away from the building. Designers will often show vents next to the field or to a tank, assuming the installer will place them where they won't be a problem. Check with the designer or have the owner call. Remote venting is a very successful way of eliminating odor complaints. Odor issues inside the home are almost always related to internal plumbing and can be very difficult to find. Be sure all traps have water. Basement sinks that haven't been in use for some time can dry out and become a path for gases to escape. If the washing machine sits in an overflow pan, these are sometimes plumbed into the drain system, and their traps can easily dry out. We've also seen plumbing that was never glued during construction inside walls. In general, the reason enviroseptic systems get blamed for odor issues after an installation has to do with the way the field operates. If the vents are drafting properly, there will be more gases moving through the building's plumbing, and any defects that have always been there will now manifest themselves. Do not use a charcoal filter to resolve an odor issue. They can restrict airflow to the point of field suffocation. The root causes must be addressed, and again, remote venting can solve many of these issues. These pictures represent a 2-month ordeal with a homeowner that had just installed a new enviroseptic field and started to notice a strong intermittent odor in the basement. I went through many of the things we've already discussed, including dry traps. He was very certain he had looked everywhere and no problems could be found. At his request, I visited the home and found these 2 dry traps hidden by the basement ceiling's insulation. The PVC trap was piped to a water softener as a backwash drain. The softener hadn't been used for years. The copper trap was cut during a bathroom renovation many years before. The solution was to cap both traps, and the odor was gone. I had sympathy for the owner because the problem wasn't out in the open. It was only out of frustration that I started to look under the insulation, and I'm glad I did. We've mentioned a draft test a number of times, and now let's see just how easy it is to perform. Pictured here are the 2 primary locations for testing. I will typically start at the tank inlet to verify we have draft to the roof stack. I will then close the tank cover and perform the same test at the D-box inlet. You can see that a newspaper rolled tightly can serve as the source for the smoke. Don't leave the paper burning during the test. Only a small amount of the smoke is needed. When placed at the top of the sanitary T or D-box inlet, the smoke should be gently drawn into the pipe. Get as close to the pipe opening as you can. I will sometimes push the paper just inside the pipes to guard against the wind. If there's a good draft at the tank inlet, the draft at the D-box inlet should be nearly the same, provided there isn't a clogged filter or water trap in the line. Don't expect to feel the draft with your hand. The airflow, even when adequate, is very slow. That brings us to the close of this seminar and the end of our certification training. We covered a lot of topics in this section, starting with the signs of trouble. Problems usually show signs of distress long before an actual failure. Our teachers always taught us, when trying to solve a problem, break it into manageable parts. We started at the septic tank because it's the primary means of treatment, and then focused on the field itself. After we discovered the root cause of system failure and corrected it, the process of field rejuvenation could put the system back into long-term operation. We also discussed some of the common reasons for odor and how to correct them. Remember that charcoal filters only mask the problem and can actually make the situation worse. On behalf of Dave Presby and myself, I want to thank you for taking the time to participate in our certification program and remind you that you're not alone during the design, installation, or troubleshooting process. If you want advice or assistance on any aspect of the system, we encourage you to take advantage of our free technical support. We may not have all the answers, but like they say, 2 heads are better than 1. And please remember to visit our website for more information and additional online training. We hope to make more classes available via the web. Thanks again.